Good evening, everyone. Welcome to our today's panel discussion on diversity and inclusion in preclinical studies. I'm Magdalena Cassandra, and together with Annie Moisan, we're going to have a pleasure to moderate this exciting and hopefully inspiring to all of you session. We also have here with us today 4 truly passionate panelists, including Solène, Janine, Kim, and James. And we'll let them to introduce themselves just in a moment. But before that, I wanted to mention what motivated me personally to suggest this topic to MPS Program Committee as an important challenge that we must address during the MPS World Summit. While I have been working for many years in stem cell field, and I was always aware of the fact that genetic diversity is often overlooked when we are developing in vitro cellular models, even though it has a major impact on how do the cells behave, how do they respond to the treatment. Only when I traveled, only truly the travel to South Africa has opened up my eyes to the real world consequences of those actions, of those disparities, as I met clinicians there who every day are facing challenges when they are prescribing drugs to the patients, and there are limited guidance, there is a limited understanding of the consequences of those treatments, as the drugs were, a majority of those were developed based on the studies in the Caucasian population. Therefore, it also additionally made me realize that me, as many of you here in the audience today, are the stakeholders whose commitment, whose real commitment and real efforts toward embracing diversity in our own studies is truly needed, and it's truly critical to progress and to realize this transformative progress. Therefore, our goal today is to discuss what can we do with microphysiological system to be more representative of the human population in non-clinical studies. We ask our 4 panelists today to prepare a 5-minute presentations, each with specific topics, examples that are closer to them, that span across clinical pharmacology, in vitro modeling, and tissue sourcing. We hope that this is going to provide you with some additional context of why it is important, what are the motivations, and why collective efforts are needed.
And so before I let the stage to the panelists, I'd like to share with you a point of clarification we came across in our discussion, in our preparation, and it's about some definitions actually. We had to clarify that between us. So gender, race, and ethnicity are self-identified social constructs not based on genetics. So not the preferred references in scientific and clinical studies and reports. So sex is biologically defined, and genetic ancestry as well. And this will be, generally speaking, in research and clinical settings, the recommended parameters to report. So a bit more specifically, what genetic ancestry is, well, it describes the biological population's origins as it is reflected in the DNA inherited from those ancestors. So you are willing to agree or disagree with these definitions, but we wanted just to clarify that with you in starting this discussion. And while I was looking up at these definitions, I found this, and I really like this representation here. On the left-hand side, if you divide the world in 7 populations based on their genetic ancestry, it will look like that, very evenly distributed in between them. However, it's also very clear that these genetic ancestry-based populations are not equally represented in human genetic studies. And here, this is one example for psychiatric genetic studies. I don't need to go and to explain. You know that, I'm sure you guess, in blue, it's European ancestry. So there is clearly disparities in where we're going there. And to add to personal motivations, perhaps, as Magda, sorry, I lost my voice last night somehow. Um, so what really triggered a motivation and a sense of urgency to contribute to the topic, it's actually when I realized that in my home country, Canada, there's a profound genomic divide, and even so that the government has launched a research-wide, countrywide program on that is called Silent Genomes. And in this case, silent refers to the indigenous populations which are just absent in genomic databases in the country. And if we want to help and see patterns in healthcare and help them, well, right now they are absent. So I think it's really critical we do something about it. So it's perhaps far from our in vitro model, but that exemplify that we also need community and collective efforts toward that. So on that, I will now pass the mic to Solène. She will elaborate on her experience with sex differences in clinical settings, so clinical pharmacology. And that will be followed by Janine, Kim, and Jim on diversity in vitro models and tissue sources as well. Solène.
So I'd like to talk to you a little bit about sex differences in PK/PD. And so why can't a woman be more like a man? This statement clearly shows the reality and sex bias in current drug development. There's huge PK difference between men and women attributed to slower GI motility, to fat mass, to different body weight, to different abundance of SIP. And this is most of the time not taken into account. We know that 80% of autoimmune diseases occur in women. However, there's still a lack of understanding of disease pathophysiology between sexes. And most of the clinical trial, when we arrive in phase 1, human dose projection are not tele-based, sex-specific dosing recommendations are often absent, and women are underrepresented. So the FDA is making a huge effort at the moment, and we have a new guidelines on diversity and inclusion to really shift the mentality and be more inclusive, but we are not there yet, and this lack of inclusion of women and of minorities really drive that we have a dose that is suboptimal right now for phase 2, for phase 3, arriving in the clinic. So we need to highlight sex-specific differences in health and disease, including difference in biology, difference in biomarkers, in hormones, in microbiota, in preclinical model, in biomaterials, in PK/PD relationship, in order to provide optimal drug therapy for all and not only for Caucasian men. So I'm going to guide you through examples where we have sex difference in PK that impact as well the efficacy and the safety of the drug. First example is digoxin. We have a higher mortality rate among women with heart rate failure treated with digoxin. Digoxin is a PGP substrate, and we know that men have a higher expression of PGP. So the drug is cleared faster than in women. Women have higher exposure. On top of it, concomitant therapy like progesterone inhibit as well PGP and can put the woman at, again, higher risk of having a high exposure of digoxin. So we have lower dosage and lower serum concentration targeted recommended in women. And this is a great example of sex-tailored dosing needing to mitigate safety risk for drugs which have a narrow therapeutic window. Second very interesting example is about tenofovir. Tenofovir is used for HIV therapy, and it's used as a gel, and we have observed a huge variability in efficacy in the clinic. So a clinical trial was conducted in African women with 2 major vaginal bacteria community, Lactobacillus and Gardnerella. And we have observed that with Gardnerella, there was a 3-fold lower efficacy in HIV treatment, which was attributed to the fact that this bacteria actually metabolized tenofovir faster than it actually is a pharmacologically active drug. So this is a really fascinating example that underlies that probably in the future microbiota should be more taken into account, and we should have tailored dose considered to reach efficacy for drugs that are locally applied but potentially also orally applied. And last case example, of course, recently COVID-19. We have seen a clear gender difference in COVID-19 health outcome, but without any information on gender targeting dosing strategy. We know that men have shown higher mortality rate and severe symptoms. We know that estrogen may play a protective role in suppression of inflammatory storm, that testosterone has been linked to pulmonary complication, and that age-associated decline in sex steroid hormones level may mediate pro-inflammatory reaction in older adults, putting them at higher risk for adverse events. Considering all this, really, sex steroid age-related efficacy of COVID-19 treatment in youth should be available. So what can we do better moving forward to anticipate earlier the impact of sex difference in PK/PD relationship, where we need to drive medicine with the totality of evidence mindset, from preclinical species, from in vitro to post-marketing. We need to report sex of cells of animals. We need to record the age of the donor. We need to include all the microbiota, microbiome information we can have. We need to include as well the level of hormones, how they fluctuate, and include minorities, women, older subjects in clinical trial. If we want to accomplish the goal of precision medicine in the clinic, then we need to drive as well precision biomaterial. We need to design materials for female and for male tissue. And I'm going to challenge you on that, because recently in a survey, it has been shown that out of 300 published papers on biomaterial, only 4% reported the sex of the cells. So we, clinical pharmacologists, need you, and we need to cooperate earlier on and collaborate really from in vitro to have all this evidence to better guide clinical trials. It cannot be that we arrive in phase 2 again with only 20% of responder. We can be better than that, but we have to do it all together.
Hi, I'm Janine. I'm from South Africa, so I bring the genetic ancestry perspective. We're here to talk about a big problem with regards to adverse drug reactions, the reasons why those happen, and hopefully an indication of how individuals in this team could make a significant contribution to solving that problem. So why is diversity important in preclinical cellular models? It should be well established across an audience like this that it is now dogma that Africa holds greater genetic diversity than any other population in the rest of the world. As an example, most populations have approximately 4 million variants in their genome, whereas as soon as you hit an African population, that jumps to 5 million. Add that to quite a unique and disproportionate disease burden. So along with reduced resources, as indicated here with our gross national income, if you layer as an example a disease like HIV, this is the situation that we have to deal with. Lastly, there is a dearth of clinical trials that take place in sub-Saharan Africa, a continent that represents over 17% of the world's population, but which has only, I think, 2.5% of the global clinical trials that take place. So what is the consequence of this? 1 in 12 people in South Africa will be admitted to hospital for adverse drug reactions. So we need to talk about how we can incorporate more diversity in our cellular models. And this has been happening over the last year or two, and it's really exciting to see this in the literature. But despite this, as an example, the Human Pluripotent Stem Cell Registry, so far as I know, still only has 3% of their stored iPSCs representing individuals of African ancestry. So let's talk a little bit about what those individuals in that team that I showed you at the beginning have been doing to combat this. We've been making induced pluripotent stem cells from individuals of African ancestry. We've also been making some primary human hepatocyte cell lines. So I thought I'd show you a little bit of data because it's been coming up in quite a few of the talks. What are the genotypes of the lines that we have? So this is an example of three drugs with their 3 genes, and I just want to show you what that landscape looks like in an African context. Let's first look at 2B6. One of its substrates is efavirenz, which up until recently was South Africa's #1 antiretroviral rollout drug. If you look at the star 6 allele, individuals with that can't break down efavirenz fast enough, so it leads to a toxic buildup. Now, it's prevalent in Europe. We see it at about 15 to 20%, but it shifts up a gear to about 1/3 of the population in the African ancestry. Doesn't sound like a big jump, but hopefully that map of HIV prevalence that I've showed you should give you an idea of how devastating it is to see in so many of our hospitals individuals coming in with adverse drug reactions that are referred to as catatonia and psychosis. Switching gears to cancer, tamoxifen. It needs to be converted into its bioactive compound, endoxifen, by CYP2D6. One of the alleles, star 17, confers a lack of functionality to the gene. So for those individuals who harbor this genetic variant, you might as well be giving them sweets. It doesn't exist in the European population, but that's going to affect 30% of the African individuals walking into the clinic who get prescribed this drug. Lastly, I want to pivot to tacrolimus. So this is an interesting angle because here we're talking about an immunosuppressive drug that is absolutely critical in maintaining post-operative outcome after organ transplant. And what's really important about tacrolimus is that the trough levels in plasma have to be maintained at steady state levels. Individuals with a star 1 genotype rapidly metabolize tacrolimus, so their levels tank very, very quickly. Now, it does exist in the European population, so it's about 30% is the minor allele. It's not the minor allele in African populations, it's the major allele. So 70% of the patients are going to have poor treatment outcomes post-organ transplant. The consequence of all of this is that we believe that we need to ensure that African diversity is taken into account in global research development pipelines. And our goal, our contribution, is to make sure that the cells that we're creating are globally accessible so that they can impact the way we manufacture our drugs and ultimately improve health outcomes, not just for sub-Saharan Africa, but that these cells can become a global solution.
Okay, thanks, Janine. Well, we represent one of the users of those cells, so thank you. We will take them readily. So I'm from Genentech. I run the Complex In Vitro Systems group there, and I'd like to talk a little bit about Genentech's efforts in this space to really be more inclusive in preclinical studies. And I want to just start by thanking Mark, especially who's the head of human genetics that did a lot of the work with Ji-hoon, Mamie, and Nandini. So, I mean, this goes without saying at this point, but I give you the kind of numbers here, which is that on the left you can see the diversity, right, of the global population, the middle, what our clinical trial diversity looks like right now, which absolutely does not represent that, and then on the far right you can see what our preclinical research is representing. So we have a far way to go. So of course, the first things we think about are how do we source the right cells from the right individuals to get at least a little bit better at representing that diversity. So cancer cell lines I'll talk a little bit about today, what we've done in that space. The iPSC line space, we would hope to get things from Janine and others that represent more diverse populations. They're pretty expensive, but we're working on trying to ingest them in Genentech. And on the right, I'll talk a little bit about our efforts in sourcing ourselves some diverse organoid lines. So we talked a lot about genetic ancestry so far, and what I'm showing you here is a TC plot of what the 1,000 Genomes Project did to look at all of the genome diversity across 2,600 people in 26 regions of populations across the world. So what we did at Genentech is we took this data, and the larger circles represent what the 1,000 Genomes Project came up with, and the smaller dots represent our internal cell lines. So we tried to map our internal cell lines using this reference on the left, which I would definitely have you all go to. It's a Diddle et al. Of Cancer Research in 2019, where they provide a user's guide, so you can do a SNP array on your cells, and you can match them to the genetic ancestries that are nicely laid out in that paper. So what we found, of course, is not surprising, which is that we have about 66% of our cells are of European ancestry, unfortunately. We also found some other problems in trying to go about uncovering genetic ancestry. One is that you have named ancestry, so that is something that comes on the vial, like it's labeled with a preconceived notion of what the race or ethnicity is, and that did not match, what we found in the SNP arrays. And then, even though those were common, we tried to realign them, but of course you're going to have mixed populations as well, so how do you treat those and where do they fall in your spectrum?
And then lastly, the SNP arrays can also capture HLA data, which is another angle and layer of diversity that we do have to try to capture across populations. Another unsurprising thing is that we found that 70% of our more than 1,000 cell lines sitting in the Genentech database were male. And even more interestingly, though, if you again look at what the vials said, we found that about 17% were mislabeled. So when we actually did the genetic test, we found that most of those mapped as female instead of male. And we think that, the general severe genomic instability of those cell lines was leading to loss of the Y chromosome with time, or duplication of the X. So when that happens, of course, it really highlights that when you get tissue, you need to do this SNP array right away, and then you need to qualify them every 10 to 15 passages to make sure they're actually staying authentic to what that original source was. And then lastly, I'm just going to focus a quick deal on building our GI organoid biobank. So that was all of our cell line database, which was mostly cancer cells. We are going to source iPSCs, as I mentioned, and here is our attempt to collect adult stem cells isolated from patients. So we started with GI to do this because the GI stem cell can be almost indefinitely propagated, so we could highlight what the differences are between the patients we're getting. So we get this tissue in the lab. I know that's gross, sorry, it's almost dinner time. And then we segment and clean it, we mince it, and we isolate the crypts, and then of course do the classic Hans Klever's method of putting them in Matrigel. But we also collect the patient's blood so that we can do isogenic studies, and these have a lot of really great impacts across Roche so far. The hope, right, in collecting these adult stem cells is that they actually maintain the epigenetic signatures from the host. So some of the things that you heard earlier about the microbes in your local environment, some of those tag the host and some are conserved. So we're trying to understand which ones and how they affect our process so that we can layer some angles of diversity and then use that to be more inclusive preclinically. And of course, these are models that have a lot of physiological relevance and are scalable. So with that, I will end and invite James.
Thanks, Kim. Welcome everybody. I'm Jim McKin. I have been working on the development, validation, and utilization of alternative methods for about 20 years now. And recently I joined LifeNet Health, based in Virginia Beach, Virginia. This is an organ procurement organization that sources and obtains organs for transplant. And what it's really done, it's opened my eyes quite wide to the need for characterization and consistency in how we harvest not only the organs but the tissues. And what we're talking about is that I believe we need control from procurement to storage of cells and tissues. We need the clinical data on each donor, and we also need genotypic data on each donor. We need to have a set criteria for how we're going to qualify tissues and cells for specific uses, and that needs to be available to all of the users. We need to have normal and diseased tissue, multiple organs, and multiple cell types. This just gives you an idea that what we're doing right now, we're moving across normal and different types of diseased livers. We can take the tissue, we can flash freeze it, we can put it in paraffin, they're banked and stored, but we also can isolate cells. So a lot of organs that don't lend themselves to transplant do lend themselves to research. And so the cells are isolated as primary hepatocytes, endothelial cells, stellate, and Kupffer. Those are all banked and stored. And each donor has an information sheet. And actually working with this amazing group here has shown me that there's some information missing. But this is what we're doing right now. So we have the basic donor information: age, gender, ethnicity, height and weight, any disease issues, medical history. Also, we have pathology. So on the right, you can see H&E staining of the tissue that was collected. And then they're scored for fibrosis, inflammation, steatosis, hepatocellular damage, etc. And so this is all the information you would get from the donor of any tissue lot that you obtained from LifeNet Health. Right now we're focused heavily on hepatocytes, but we also have human thyrocytes and lung cells that we're banking and storing for research, and as well as transplant. But in the hepatocytes, cells, everyone here probably knows that some hepatocytes set down very nicely and some don't. But the ones that don't can be used in suspension for other endpoints. So viability of the cells and recovery yields are very important. They tell us something about the tissues. I think platability is important. Cell attachment, efficiency, percent confluency, etc. And finally, histology. So we do have a picture of each of these organs, whether they're normal or diseased. And lastly is our ethnic diversity, which you can tell from this table is not great. We've mostly European, African American, Hispanic. Now, I just want to point out that we're currently only sourcing tissues and cells from the United States. And clearly, to be a global group, we have to start putting organizations, tissue procurement organizations together. But again, one of the populations that jumped out at me is Asian. So it's very difficult to get Asian tissue. And I think partly could be cultural. I don't really know. But I just think it's something that we really need to stay focused on and we need to work on so that we can improve this library of cells. So I think, this is our team at LifeNet Health, and I just think for me the idea is that we need to be consistent in how we collect cells. We need to record that, and we need to share it with all of you so that you know what you're using. Thank you.
Thank you very much to all the panelists for providing us with real-world examples and your personal experiences and your personal perspective of where the problem lies, so as we can start thinking of and truly implementing solutions. We could, of course, go on for hours and hours by highlighting additional cases in which disparity in research, drug development, and global health exists, right? But for the moment, we would like to stop here and start to think about practicalities and integrate all of the topics that you just have presented, so as we can start thinking as a community how we can position our preclinical models in the center of this problematic. So our first question we would like to direct to Solon and Janine. You have highlighted how the gender differences and genetic ancestry can lead to unanticipated adverse drug reactions because they are, of course, poorly accounted for during the preclinical stage of drug development. So how could we integrate your expertise in clinical pharmacology and in vitro models of drug metabolism to firstly identify what matters and what to focus on? Secondly, how to better capture diversity in our preclinical models? And lastly, demonstrate their relevance in recreating such diversity and accurately associating it with treatment response in PK/PD and safety and disease phenotypes.
Thanks, Maida. So I can start. So what really matters right now still for us in the clinic is that a dose based on a Caucasian man does not fit all. And it's always the case that we have this dose provided in phase 1, and then we arrive in phase 2 and start to see non-responder or a population that is completely different. If I look at one of my last clinical trial, we started in Europe, 95% Caucasian. I had 3 African American by chance, and those guys actually had a much more higher exposure in metabolites, which was putting them at risk for safety, and then also they had less exposure of their parent, so then they were at risk also not to show any efficacy. And on top of it, then we saw that those 3 patients had a polymorphism in their SNP that the Caucasian didn't have. And then we were moving to phase 2 in the US, to Texas, that has a population of African American that is much higher than in Europe. And I did not know which dose to put. Am I decreasing the dose? How do I tackle that? I had absolutely no information. All that because we constantly arrive in the clinic with a dose that fits a Caucasian man. And this cannot be. So I think the problem is that there's a lot, tons of preclinical data that actually do not arrive to us in the clinic. And maybe because we don't talk to each other. Also between big pharmas and academy, we don't talk to each other. There's great models in Pfizer, in Roche. Do they talk to each other? No. So this is, again, I'm going to be a little bit provocative, but this needs to be a community understanding that we need to share data. And for this, as far as I'm concerned, we need to feed really the organ on a chip tissue. There's male, there's female, but there's also transgender. Let's not forget this. And combine all these with quantitative system pharmacology. And only then can we be more precise when we arrive in the clinic. And so this is where, Janine, I think we need to find a way to really build all those models based on your data that, to be honest, I did not even know exist, because I don't even know where to look at to find what I need.
So Janine, can we replicate this diversity in your in vitro models?
Yeah, so I think this audience is fairly comfortable. George Bach said no model is correct, but some are useful, and we have to be cognizant of that. I think one of the things that I love about the primary cells and the iPSCs is that they can actually integrate at multiple steps, right? And it depends on your question. So whether it's from something early on, like drug discovery, through all the way to the end towards supporting clinical trials, making sure that that information becomes available, to post-market surveillance. What if there are things that are coming up and we want to try and have an idea of what's going wrong? They could provide information that could support rapid decision making. So I think that needs to be applied across the board. But it's also just worth mentioning that the other thing that's so important about these models is that I think we think that they're only going to apply in an African setting, for example, of what I've shown here. And one of the things that I think is really important linking this is that rare genetic variants that are creating problems in Europe, and they do exist, it's often very difficult to create causal associations as a result of that variant to an adverse drug reaction. Those variants are not rare in the African population, so they won't be 0.5%, they'll be 5 to 10. So integrating these a whole way through the pipeline, and as Solen was saying, having that communication across the board, understanding what we are working with, I think could make a really big difference.
Thanks, both of you. So now I have a question more directed to Kim and Jim. So both of you know well the world of investigative tox, preclinical safety. That's where you're mainly active. So in your experience there, what would you say is the biggest challenge in achieving diversity and inclusion in preclinical studies or in our models? And have you identified a good strategy and approach that turns out to be effective for you in these challenges? Kim,
yes,
ladies first.
I wouldn't say there's just one challenge.
No, I know. The biggest.
Yeah, so I'll highlight a couple because I think that they're really salient, which is, of course, if you're working on experiments in the lab and you have one pair of hands and you're told to do 5 donors instead of 1, that is a very different workload, right? And especially when you're not sure if all the differences are going to come out or what they mean, or if you're going to be a signal above noise, or, there's a lot of questions that researchers come up with. One reference I can point you to is from Capes Davis, actually out of Australia, and she provides kind of a framework where it shows, look at genetic ancestry, look at sex, and, try to pick these from these couple of places when you're picking your cell lines, and what are the considerations for picking those lines out. So at least that's a place to start, but I think the challenge is figuring out what you're going to pick, and then also actually having the labor time to do the study, and then understanding the signals that come out of the study. So at Genentech, to solve some of these problems, we've put in place a bunch of automation that is here or is coming in order to kind of absolve ourselves from the problem of, the person in the lab just doing their one donor all of the time the same way. And then also incorporating multiple readouts. So when you're looking at something and not just looking at, say, cytotoxicity, but you're looking at a combination of cytotoxicity, biomarkers, TIR, and then you create a score based on that, that might actually be more consistent than just one readout for one donor. So yeah.
Yeah, I agree with all that, and in my experience in preclinical discovery work, I think educating management is really key too, because to be honest with you, if they're not asking for it, you're probably not going to deliver it to them. And as you know, in preclinical, we're really geared up to go to rat and dog, at least in the United States. I wish that weren't true, but fact is it still is. And so what we need, just before that preclinical safety study, we need to incorporate this diversity in the drug-drug interaction studies, where we're using human hepatocytes and human cells to understand SNPs and to understand basic metabolism issues. And I think if we had a sense of of management needing that information and then having a diverse pool of tissues where we had the right information, we could start getting the drug-drug interaction information just as we're going into preclinical safety studies, and that would inform our clinical trials, right? Because if you find something off in the DDI work in vitro, then you can select different groups and make sure you cover those groups in your clinical trials.
That's great. Could you please also comment, you mentioned that we need to start doing, what about reporting? What about the fact that in materials and methods we do not always say what's the sex of the cell line that we are using, what's the genetic ancestry? We all may know, but we are not doing it. Could you please comment on that as well?
Right. So one of the really good recommendations from that KB Davis paper that I was telling you about was that in all of our studies in materials and methods, when we know it, we say it. So what are the key biological metrics that we know about, and are they either supported by genetic ancestry that you actually did with genetics, or are they just named, right? Something someone identified. So actually calling out those differences is a place to start for everybody. Just start there, and let's see if we can collectively build enough data.
Yeah, I'd like also to go back to the collective effort. So Solène, you touched on that. That's very important for you. You see, like, how do you reach out? You are not aware, so how do we raise awareness? How do we work together? So who do you consider? So that's a question for the four of you. Main stakeholders in this, if we have MPSs centric to the problematic here and we want to do something about DNI, who are the stakeholders? How do you perhaps propose to interact with them? Stakeholders either close to you, distant to you. Do you see a roadmap? Do you see a space there?
Okay, if I go? Yeah. Okay. For me, I think if I were a regulator in Europe or in the United States, FDA, and my job was to make sure that the global population was safe for any given medicine or dosage, I think they would be a pretty major stakeholder. And when they start asking for the information, which they are now, then we're going to start giving it to them. And so I think, for me, that's where the stakeholder starts. And I'm sure that there's like 13 more stakeholders that others can.
Maybe 3 more, perhaps?
Yeah, so sorry, just to add to that, it's quite interesting, and maybe the advantage, one of the things Africa has a habit of doing is sort of lagging behind on some things, and then we sort of, we frog leap over other things when a need requires. So for example, we've got a very innovative regulator in South Africa, SAPRA, that has been approaching us to talk about innovative ways and how they could deal with it. So that's, it's really helpful to have that kind of that interaction. But I think, stakeholders across the board, and this goes back to Solène, what you were saying, is that it has to be at almost every single level. So if your team at the clinical coalface is you want them to make rapid turnaround decisions and understand the 2 or 3 samples that they've got, we have to give them as much data as we can that we're sure about. I suppose, it's not going to be absolutely perfect, but provide them with information so you can make those decisions along all the way along that step. But just going back to, so again, it's stakeholders across the board. But just going back to that is something that I think is quite important as well. When we speak about pharma and research groups and regulators and many different individuals, but we also need to, for the cells that we are acquiring, which is primarily healthy tissue, there also has to be buy-in and engagement from the community that is supplying those cells. And that's vastly different from a global point of view in terms of cultural practices. So it might be commonplace for most people in this room, to feel very comfortable with doing that. But in the 90s and early 2000s, every time you went to a rural area in South Africa to take blood, the patients were refractive to it, because you would come back with, we've got the injection, and come back with information that you had HIV. So they don't want to go anywhere near a needle. Or giving away pieces of tissue that have cultural implications. So I think, yes, stakeholders across the board, but global understanding of what's happening in different regions and buy-in by the communities, I think, is really important.
How about money, maybe? So funding agencies. So how do we resource? How do we resource sponsor these efforts? Who should we also convince that this is so important and potentially transformative global healthcare. Still, the money perhaps is not there sufficiently, I hear. So what do you think? Should we have more funding calls on this topic, and how do we convince?
Well, clearly we need more funding for everything, but
Yes.
I think for me, the the idea that we could have consortiums of diversity, like we do for, like CASI-U, for example, for studying the safety of cosmetics. I think it'd be wonderful to have a consortium that was focused on diversity, which would provide fundraising from multiple countries globally, but also could oversee the standardization and the information types that were available to the researchers.
Data collection, data sharing probably involved in
Exactly.
included in that.
Yeah, so places like the Thousand Genomes Project, those types of projects, I think we just need to do them differently maybe next time, right? Or, they did their work and it was great work, and maybe we can, extend. There's also, I think NIH, if I'm not mistaken, has a research for minorities, actual group. Yeah.
Free Africa. Yeah,
Uh-huh.
there were various programs in the past.
Okay, yeah.
Yes. So just one more thing to add to that, and so yeah, H3 Africa does extraordinary work in trying to increase representation of whole genome sequences, amongst other things. But it's something else just to remember. Having an African line doesn't mean Africa's not a country. So one line isn't going to work. It has to be regional. It has to be pan. And I'm speaking as if I'm representing Africa in totality, but it obviously applies to other diverse regions as well. So that concept of we've got one line of African ancestry, really, you've got something, but it's really not covering the broader spectrum. And it should, right? Because there's advantage to doing that, to being able to have such incredible diversity that removes noise and extracts true signals that might be creating associations, I think is really important. So having that funding appreciation of that, I think is really important from a cellular point of view, not just from the genome.
In one of the articles you shared, Janine, I found very, very insightful, and reporting on percentages of, in IPS collections, for example, the percentage of the different background, genetic ancestry background. And so we are improving in the data, in the IPS line collections of different efforts worldwide. So they are more and more from African and other background. However, this has not translated yet into their use in the lab. We're still using mainly the same iPSC, so we bank them, it seems. That's already a good start. But I guess we have to do more in terms of using these cells in our models as well. Is that what you think as well?
Yeah, so it's about accessibility, right? So we've been, I think, my team's been jumping. Our lines are all of Black ancestry. It's because that's the majority of the population. So that's just the state of play. And I think that's where one of the advantages, and I'm very grateful to be on this panel, is to promote this idea that we have this capability. We can do it. I have an extraordinary team. They're making these lines, and I think that if we could try and find a way to have mutually beneficial partnerships that have that collective respect, where there's this understanding that we're being very careful about the way that we are acquiring these, but we really want them to be globally accessed, because that automatically has an impact on our population. It means that throughout the drug development pipeline, the drugs that eventually find their way back to our country, our region, we'll have taken that into account. So it's a win-win.
Well, it's time for questions, huh? I think we would like certainly to hear from you in the audience. Comments, questions, please share your experience. I think we start over there, Magda, and then we'll circulate. Yes, thanks.
Yeah, Dan Tagle from the NIH. Thank you for taking on this very important topic. I just wondered, just to add granularity to the discussion, how would you consider admixed populations, that is, individuals with mixed ancestry? Because all the categories I've seen so far are very categorical.
And I will add to that transgender.
So I think we need to be careful about using the language admixed as well. So one of the difficulties we have in a country like South Africa is that that terminology could lead to people having the feeling that they're not a pure population. So there is a problem with the language, right? I don't want to get into a massive discussion about that. I think it's important, but I think we're generally talking about greater diversity across the board. We have samples that would be coming in, because South Africa in itself is so very diverse from that point of view. Those samples would be incorporated. I'm not sure how the global repositories are doing on that front. It would depend on how they are labeling those populations.
Hi, my name is Elaine Faustman, and this is a fantastic dialogue. In particular, I was especially pleased, Janine, that you called out the idea of the stakeholder, including the actual donor and the donor populations there. I work in a school of public health, and community-based participatory research, and so we hear a lot of reasons why the general public does not want to be involved in these. And I go back and think about some of the early work with prostate cancer. That was a disaster. We got very little participation in this from particular populations in the U.S., like the African American representation, although hit hard by the disease, was not participating. And the simple answer was, what is it going to do for us? Just because you diagnose us, we cannot access these expensive medicines. And this is a common endpoint. So as you know, the WHO guidelines for how you implement clinical trials around the world have some very interesting ethical constructs of that. It would seem like the Physiological Society could come in and start to talk about what those mean for donation. That would be a fantastic blueprint on that. The last very practical comment here is that over and over I saw how people are putting together their platforms, and it was a point of combined analysis, in juxtaposition to what we're talking about as precision medicine. There has to be a happy medium between those that we can do. So I would encourage us that just putting 5 or 10 individuals together is not, in a composite. Even the very basic of composite statistical analysis provides a lot of other guidance as to how to pull out that diversity. So again, fantastic presentations.
Thank you. I think we can take, or do you want to comment, or we go with the next question?
I would just say that that's a really good point, and I think that for me, the coming together of, I think Janine's point earlier about regional importance is really huge. There was a recent clinical pharmacogenomic study done on Ecuadorians, and they showed that they could identify in terms of the ADMET, the CYP2C19 and 2D6 SNPs. There were good metabolizers and poor metabolizers, but what they found was that when you factor in the phenotypic factors, the epigenetic, that actually good metabolizers could all be quite poor metabolizers based on their environmental surroundings. So I just think that's just one regional area. You can imagine what Africa would be like to address that. So I think it's pretty amazing.
Yeah, thank you very much. I'm very happy that this problem is exposed. And what we used to call evidence-based medicine, it turns to be non-evidence-based medicine that needs evidence that we should develop. And it's nicely said, nice words, but we need some action, probably plans to take this forwards. And I have a list of things, but let me mention 2, 3 things. One, probably we have to revisit the definitions, terminology. As we speak about standardizing terminology of MPS, we should also revisit those terminology. Okay, the genome is one thing, the exposome Thomas spoke about is one thing, phenome, geographome, different things. You cannot just classify, say, ethnicity. You go African, European, Asian. It's more diverse than that. You can be in Africa, but you're European in a genome, and then Japanese in Japan might have different health problems than the Japanese in America. Anyway, just to give an example. So revisiting terminology and those classification will help us then tackle the problem. Two, question what in MPS could contribute. Before, probably we have an excuse we couldn't do it, for we need so many patients. Now with MPS we could cover a lot of these gaps, and we develop probably evidence-based medicine. So I suggest forming some working body or special interest group within MPS that we could lead or raise the orientation, do some actions on the level of the world in future. And three, to be able to implement this, you need the funding. An example is what NIH is doing, Dan spoke about yesterday. So directed funds to these, so we will see projects and things. And the project probably proposals in future, the proposer should be asked what and how they consider the diversity in their studies. Today we're asked only probably on how we consider the sex issue. The last one is how legislations, regulatory body would ask for these things. So for the stakeholders, the companies, maybe the things will get more expensive to go that route, but in the long term, for health service, they'll be more cost effective, but it has to be enforced by some regulations and regulatory body. Thank you.
No, one thing that we could consider is that when people do get funding for these, maybe a component of that funding could be an educational component, as the nice lady was saying earlier, where, you know, if you get funding for this, maybe there's a portion where you have to do workshops and you have to talk to the public about, you know, what they're doing and the implications of what they're doing. Other things that we're considering at Genentech that are very, very early days is kind of doing iPSCs like village in a dish. So, you know, what if we just took them all and threw them in and barcoded them, and then was able to say this cell responded this way, right, so that it's not so laborious, like everything is a separate experiment, right? So, yeah, there's a lot of ways we're thinking about it, but those are a few.
All right, all the way in the back here. I have actually two very, very different questions, but I want to start with one comment that we are not doing a good job right now. We did a study in 2018 where we looked at the reporting on organ ownership and MPS, and it was the same there. We had majority of male, and the few not male were just unreported. So I think that can be much better. Then I have two different questions. The first one, should we break with the dogma that we use the same culture media? Because we talked a lot about genetics, but sex difference is much more than just the genetics. But we use the same culture media for every cell type. Should we break with the dogma? Should we have a male and a female culture media, which we use with male and female donors? So that's the first question. And the second question is, we talked about a lot of the getting kind of diversifying the cell banks we have. Is that the right approach, or shouldn't we shouldn't we better look into how do we get the technologies globally distributed? How do we get access in, let's say, less developed countries to use these complex model systems to run the studies there?
So to your, and I think your last question is really important, and it actually links to a comment that was made here. And I hope I'm not going off piece too much on this. I'm not going to talk about cell culture media. That's someone else is going to take that one. But I think what comes down to this, and we think about it a lot, you have to give your clinicians enough information for this to have impact. It's about impacts. What is it going to do for the patients? And to do that, you need your clinicians to have the right information. So what if, in your suggestion, I think diversity needs to be included, and I think the technologies need to go elsewhere, but across the world. But you could prioritize based on disease burden, genetics that are creating problems. What are the key? Like, so if it's an efavirenz for South Africa, as an example, we have other problems. It's not just HIV, right? But if you could prioritize based on that to support local clinical trial implementers, then maybe not everyone is doing everything, but different regions are prioritizing based on what's killing the most number of people, what's creating the most number of adverse drug reactions. So that idea of, I think it's both.
I think your question about standardizing the cell culture systems is key, but it's a huge project. When you think about addressing all this in in this short period of time, it's kind of mind blowing actually. But But the culture, as we develop IFUs, instructions for use, as we get into different types of cells from different ethnic populations, I think the IFUs should grow. They'll grow with those as the tissues get banked, and we'll have information for optimizing the growth so that it's all standardized once again.
And I guess if I could try to help give some guidance, if it's even possible, it would be that if you're a researcher in pharma and you know your question, right? So you know exactly how your drug acts, what CYPs are important, then you can start actually picking the right cells, because you can go to those SNP arrays, you can find those, you can do that a much more linked way. But if you're a general researcher in academia that's just making a general model and someone says be diverse, you don't know what that means, right? So what you could do is, if you did have your hands on multiple cell lines, and if you did put them in your system and you got to enough statistical power, and you tried different media formulations and you could relate the differences, that's the fundamental research that will drive any change, right? So go ahead and try to make those inferences, and really get tight with your biostatistics people, right? And understand if you could figure out what those are to help the community.
Yeah, and I think getting academia to buy into this too, because it's going to take, for industry to do it, it takes funding. What I mean by that is management has to decide they want to pay for that, and that's not always easy. And I think to start doing more partnering with academic labs where the basic research is going on with the students and postdocs, I think we're going to be able to get it faster, move through the industry part, because once they see the value, they will start putting money into it.
My comment about the cell culture media for the female and male, it's definitely needed, especially for the reproductive studies. Phenol red only, it's known to affect the female hormone production, so be aware of that, and it's definitely the topic that we should be going back to.
Okay, I'm Akira Hisaka from Japan. So for Japan, ethnic difference is very important, and for this reason, probably more than 40 years, Japanese regulation requires phase 1 study must be conducted in Japanese population, separately from Western countries. For this reason, there are so much information of ethnic difference in pharmacokinetics between Westerns and Japanese. And recently, we analyzed these differences for more than 600 clinical studies for more than 60 drugs, and found that actually, as you mentioned, depends on the polymorphism of CYP clearance is different. In the case of ASEAN, 2C19 polymorphism is extensive and parametabolization is more. And 2D6 polymorphism is also a little bit different. And other than this, we don't see any evident ethnic difference. Okay, so probably we know the mechanism of ethnic difference in pharmacokinetics in various ethnicities. But important point is we must not adjust dosage of the country depending on the polymorphism. Because even in Japanese, there are extensive metabolizer of 2C19 and parametabolizer. So important point is adjusting those depending on personalizing is important. So you should not adjust those depends on the polymorphism in Africa also. So in that case, diagnosis of individual polymorphism is more important. And such alert should be raised from in vitro study or MPH study. So role of in vitro study and clinical study is very different. I'm also involved in drug interaction guideline worldwide. And as you mentioned, so based on in vitro data, we need to design clinical study. So raising risk, finding risk is important for clinical in vitro study, but preciseness is not good. So actual adjusting dose should be based on clinical data. So it is also important to adjust sex difference. So in some cases, we find that actually very big difference, but it's very rare. In most cases, men and women is similar. So in that case, if we find some difference from in vitro study, we need to conduct clinical studies very carefully. However, we should not require to conduct a clinical study separately from men and women.
No, yeah, definitely it's drug dependent, and also
Yes.
depending on their therapeutic margins. If you can allow huge variability and have little effect on efficacy, then you're fine, but all needs to be the risk. So precision medicine has also, of course, this balance to take into account and its challenges, but this is not for all drugs that we're going to have a specific dose. Also because from CMC formulation, it's just impossible. There's a cost associated, so it's an ideal world.
So recently, so international clinical study is very common. So we need to participate as many ethnicities as possible. We need to analyze very carefully.
Yeah, fully agree and stratify, yeah.
So based on this data, sex difference and polymorphism difference should be adjusted as needed. That's my opinion.
Thank you. So I will go back to your comment, Kim, about the village in a dish or population type of the screening. So we are building those at Cincinnati Children's using induced pluripotent stem cells, replicating various ethnicities. But what I face up as a challenge, it's what's the size of the population big enough? Are you looking at the haplotypes? Are you looking at the polymorphisms? Do you know what kind of diversity you want to model with it? What's good enough, right? Is it 8 donors? Is it 25? Is it hundreds? Where can you start and really do it right? Kim, would you like to comment on that?
Thanks for the hard question.
No problem.
I don't think we know. I mean, that's the issue, right? So I think we have to really be careful in specifically designing a study, defining the success, right now we're looking at genetic differences because that's easier, so when we, to understand, some of our disease models, but I think there's so much more to be done, especially in the area of safety, especially if you know that SIPs change. I mean, there's so many things I can't really think I could elaborate now.
The context of use first, and then what's your population should look like.
Simon Fennell, UK HSA, and just following on the comment that you just made, you almost took the words out of my mouth. These presentations have been great, but it is focused on drugs in the kind of traditional sense of the word, and there's a lot of immunotherapeutics and interesting immune products out there as well. And it's just an appeal to Kimberly and James for the C of A's that you generate to please include MHC, HLA haplotype in the information, even though we may not need it. And it's a unique moment because we can get ahead of clinical studies here and have that information so that when we start looking at Bayesian analysis, we might find that there's a haplotype thing that wasn't visible in a clinical trial because that data's not there.
Well, actually, there's a lot of efforts internally. So I think internally in Genentech, we've collected enough PBMCs to represent 98% of the HLA diversity because we have drugs that are HLA dependent. So that is something we're actively thinking about. Yeah, and thinking about making iPSCs from all of those at this point.
Yeah, I can say too that at LifeNet Health we are also very focused on the HLA and the immune components. So I think it is happening. I think the data will be there as the libraries and the databases grow.
Data sharing is always a challenge, right? So I think the societies like the one that we are currently building for microphysiological systems should really think a lot about that, of how we're gonna actually share all of that knowledge that right now maybe in the pharma, maybe in academia, maybe in specific programs, how we build repositories that are open to everyone.
Hi, I have a question about informed consent. I'm from South Africa as well, and I deal with patients on a weekly basis getting informed consent. In developing countries, you have to assume that there's a very wide range of educational achievement. So we deal with people who cannot read or write, for instance. So my question is actually to Kim and to Janine, because you've been bandying about how you're going to sell cell lines or give iPSC lines to Kim. I have quite a big problem with commercial companies taking cell lines from countries that have a big power differential. And so these include African countries, some Asian, etc., basically the global south. So how do you think that you currently do in terms of getting informed consent? And I know that you probably use vendors and you'll shift the blame on them or say they do their job. But do you think that they do their job well enough? And do you think that actually you should be doing a lot more or not?
Thanks, Homan. Yeah, and it's an important question, right? Because we want to make sure that, I mean, I wrote notes about that these samples are treated with respect and that they are ethically acquired. So we, in the informed consent that we've been dealing with up until recently, certainly for the lines that we have so far, we work very strongly with healthcare practitioners who are experts at this. One of the things that you spoke about education, and I hear you there, but also language is really key, right? Because if your informed consent form's in English, you're going to have a problem when you come to South Africa. So oftentimes our ethics committees, who are certainly mine, the ones that I deal with, are incredibly robust. And so considerations for language, consent forms in multiple languages are really, really important. If I may just sort of link to your point about finding ways to give access of these to the global north, I suppose. I would argue that to hold onto them with our limited resources would be a disservice to the population, to the people we serve. Having said that, there's no reason why we can't work with people who want to access these and build technology localization in regions like South Africa and elsewhere. And I very much see this as a partnership where we are getting, we can incorporate these lines and all the different variations of drug pipeline development, think about those ADR statistics and what might be different. I hear what you're saying, and I think we need to be careful about it, but I think the benefits towards the people we serve would be greater than not sharing. But I hear what you're saying.
We've noticed in organ procurement in the United States, which I understand is much different than South Africa, but of course there's the donors give consent, and what you have to realize is that somebody's dying, and the donation of the organ is going to allow someone else to lead a better life. And so oftentimes the families, if the organ can't be used for a transplant, but the tissue has value for research, they'll still sign a consent form for that. And I don't know the process in South Africa, but that process seems to work very well in the United States for that.
And I'll just add a quick point. I understand the hesitation, but I do agree with Janine that, you know, the risk of not doing it is worse because now you have 1 in 12 patients coming in with adverse drug reactions, right? So, but at the same time, what we can do better as, you know, big pharma companies is to explain how we keep these samples in-house, how we use them. We do have a massive chain of custody system where we understand what they're being used for, which labs have them, and we don't distribute them to third parties, right? So explaining what we're using them for and how it benefits, it's the whole education part I think that we can do better.
And I can add to that collective efforts. So you guys should be kept as the stakeholders, as the participants in all of that. The data should go back to you, and we should be working together to establish the populations in the countries of origins, right? And enable you to do the research that we are doing right now in here. The question is the funding, right? We have those discussions with Janine. We are building iPSC banks here in the United States. We are doing it in Africa. Let's work together. Let's share resources. There's logistic problems. There are ethical issues. There's a lot of things to consider. But, you know, till we collectively work together and push toward the same directions, I think we can get there.
Thank you so much for this excellent discussion. So I'm a scientific editor. I work for Nature Communications, and we mandate reporting of sex for cell lines, and the same goes for human research participants and tissue donors. And we actually ask our authors to explain if sex was taken into account as a variable. But I was wondering if there's something else we could be doing, and I realize we're a small piece of the puzzle compared to regulatory agencies in pharma and so on, but I would just be really curious to hear from you if there's something else that we could be doing better.
Yeah, I think it's already super nice to hear what you're doing and the great effort you're doing in that. Of course, sex is just a component, and there's so many things that can impact the disease severity or where the donor come from, and we don't know. So I would not know exactly what else to indicate you. I think already sex is a good strategy. Probably hormones as well at some point, but it's, yeah, I don't know what you guys think.
I think it's great because you're one of the forcing functions, right? And it's the same forcing function that got everyone to put their, genetic data into databases to share it, right? So you do have a really large, powerful role, actually, more than you might imagine. So I think it's really cool if you guys would think about how to standardize on that, right? So if it's gender, maybe we start asking about genetic ancestry, maybe we start asking about HLA. So think about what are the categories that are super important, and maybe you don't mandate it, but you ask, did you consider, and if you didn't, why didn't you? Was it not available? Because then if you take that data and you tell the rest of the community why people aren't, right? Even if you don't mandate it, but you get the answer, right? Then we know where the holes are. So maybe that's a start.
Yeah, I think it's amazing. I think you have to keep doing what you're doing times a million, and and that's the information forward, the movement and education of the population is what's going to keep driving keep the momentum going, and it takes that writing in a layman's terms too to help everyone understand, not just scientists.
What is needed, perhaps a bit more guidance on what information is needed given the context of the publication, the content and the cell type. So HLA, well, yeah, if we have a T-cell study and testing different molecules and different interactions, would make sense to have the HLA. So some sort of guidance on what to look at and when, because you can't ask everyone all the time to provide all the full sequencing. That would not be realistic, but we should definitely think about that, a bit more guidance. So thanks a lot for your comment. Really appreciate that. So thanks everyone for staying, and you're not there the whole night, but I guess until tomorrow, so we have still time to interact, and thank you very much. So we're really open to feedback and next steps, actions, and to do that together. So thank you for coming and for your questions, and thanks Magda and the panelists.